Good morning, everyone. Nice to meet you. Welcome to the summer break annual lab tour event. My name is Mulu Galetu. I am a senior research associate at Professor Gunning Lab at CPS department at UTM. And today we will have a lab tour, and I am working in a research lab. By profession, I am a cell and molecular biologist working on anti-cancer drug development project. This is an annual lab tour event that we are working every year. The lab tour event takes place twice a year, March and summer break, with the help of CPS department and all the Gunning group, Professor Gunning and all the Gunning group. I believe this program is a unique opportunity to benefit our community in Greater Toronto area. I have also been seen the result that former high school student, they joined the university, UTM downtown campus, Queens, Western, all over Ontario. The people who came when they were grade 10 or grade 11 or grade 9, now I'm seeing them growing up with their career. Some of them are graduating and getting jobs. I am so happy with this progressing this project, and now we expand this project, and we'll have more kids involving, and you will enjoy this lab tour event. So this project will not be successful without the help of lots of people here at UTM and from our community. I would like to thank the chair of our department, Professor Lindsay Schoenbaum, and the research manager of our lab, Dr. Elvan Diagio, who will presenting today at Center for Medicinal Chemistry. And I also would like to thank Rose Antonopoulos, our administrative assistant. Without her help, we cannot do all this. She arranged everything here. Thank you, Rose. And I also would like to thank our speaker today, Mr. Kwame Diko is with us today. And later today we will have a speaker also, Dr. Anna Ampao. She was a former postdoctoral fellow in our lab, but now she got a job at GSK. She's joining us later today. And also Dr. Amsale Belai, senior laboratory manager at Sian Health System. She's also joining in the afternoon. Dr. Fissaha Yacob, he will join us. He was on the road. The traffic is bad, so because of that he's late. He is a professor at Hamburg College and director and co-founder of Kuras. Mr. Zarihun Adisu, he will also join us. He is a PhD candidate at UFT. He's specialized in policy analysis and peace building and social justice. He will join and talk to you guys later today. Ruth Alamayo is a neuroscience student. She was a former high school student like you. She joined UTM, and she's a last year student here at UTM, and she will come today afternoon and give a talk and tell you what was her journey. And I also would like to thank Gideon and Jess from Physics and Earth Science lab. They will show you later today the Physics lab and Earth Science lab. And also Branda Pitt from Teaching Greenhouse Biology. We will see the greenhouse lab also. I want to thank Berhan TV from the bottom of my heart. Thank you, Berhan. I sincerely appreciate all of your assistance and support for all of these years. Every year you are coming early in the morning, recording all the information and sharing to the community, sending information and advertising for us, and that's so nice. Thank you so much, Berhan. Thank you all. I would like to invite our research manager, Elvan, to give some presentation for you guys. Thank you.
Thank you, Mulu. Thank you, everyone, for coming. It's my privilege, my honor to be here to work with you guys today and to help you explore a lot of different techniques. And really the purpose of today is to give you exposure to a lot of the different resources that we have today and at the university, and to maybe broaden your horizons in terms of some of the opportunities that are available to you. So one of the important things, though, is that we're going to do this together, and I think it's really important that everybody sort of has a understanding of who your peers are today. And I think what would be good is if we go around the room and maybe you guys can introduce each other. But maybe to make this a little bit more engaging, a little bit more exciting, maybe everyone can partner up and maybe take 5 minutes just to sort of talk to your partner, and then after 5 minutes you'll introduce your partner to the group. Awesome. Thanks so much, everyone. I hope it was interesting to talk to hopefully some new people too, and you'll have the opportunity to meet with everybody as the day goes on, and also with some additional potentially mentors and other guides throughout the day. So I'm just going to give you a very, brief overview of some of the work that we do here, some of the things that you could potentially be interested in. One thing that we do is really a lot of drug discovery. So we focus on what we call medicinal chemistry. And one of the key highlights, at least for the morning, is that you'll spend some time going through a lot of the labs that we have and how we've built up a workflow to explore different interdisciplinary items such as chemistry, biophysics, cell biology, mouse models. So we've tried to build all of this together. And I just want to give you a brief overview of all of this. And as Dr. Mulu mentioned, a lot of what we do is focus on medicinal chemistry, right? And medicinal chemistry is, you can think of it as what we call the birthplace of drugs. So what we do in the lab is we spend a lot of time designing and trying to think about how to build new drug molecules. And then we actually go into the lab and we synthesize these molecules and we test them out in different ways. So it's kind of the birthplace of drug candidates, and we do a lot to try and get these molecules from the bench to the bedside. And I won't really go too much into this, but the paradigm for how drug discovery works has really shifted a lot in the last 15 or 20 years. So before, maybe about 15 or 20 years ago, it used to be done by these massive companies. So these huge, big pharma companies, they would spend a lot of money, a lot of time to try and get a drug into the market. So maybe I can just pause there for a moment. How long do you think it takes to get one drug from the lab, so from the lab into, let's say, the clinic? Does anybody want to throw out some numbers, like how long? Yeah.
A year, 2.
1 year? Yeah.
10 years.
10 years? Any other guesses? So the number is actually something around 15 to 20 years. So it's a massive, massive scale in terms of trying to get something to the market. And how many new drugs do you think come out every year? So the drugs have to go through this very high regulatory process. How many drugs do you think get approved by, it's called Health Canada, or in the US it's called the FDA, but how many would you say? Thoughts? Anyone? Yeah? No? Anyone want to just throw out a number?
30.
30, that's actually spot on. So it's about 30 drugs a year. So it's not that many if you think about how many people are working on all of these, getting these new drug molecules, getting all of these new molecules into the clinic. So, and what's happened over the last 10 years, as I mentioned, is that it used to be a lot of these big companies that were working on this, but now it's kind of shifted that now all of these smaller groups, for instance, even academia, so even what we're doing at universities, things like that, we're actually doing most of the groundwork, and then industry will come in and try to capitalize on that, to at least work with partnerships. And it actually works a lot better because, as I mentioned, it takes about 20 years to get a drug into the market. The cost is something like $1 billion to $2 billion. So it's very expensive, and by having these types of partnerships, it helps quite a bit. And that's one of the things that you'll see today is that we've really built out here is trying to essentially have all of these different pieces come together within our lab, within the university here. Okay, so what we do and what we work on are a lot of orphan diseases. So these are diseases that are not as common. They're called rare diseases. We also do a lot of work with different types of cancers. So I'll just give you a little bit of background, and I'm sure some of you probably know most of this already, but the human body is composed of many different types of cells. So there's brain cells, there's heart cells, there's fat cells, there's nerve cells, but there are all these different types of cells. And even though they're different, they do have something in common, okay? And what they have in common is that every single cell in your body carries your DNA, okay? Does anybody know what DNA is? DNA? Anyone? Yep.
Can I guess?
I'm sorry?
Can I guess?
Close. So yeah, that's basically it. So DNA, and you can see it here, it's basically these long strings, and it contains all of your genetic information, okay? And every single cell carries your genetic information, and that's unique to you, okay? Now, your DNA is basically a blueprint. So it's a blueprint for who you are. And if I go through your DNA, or if you go through your DNA, you can find information, for instance, for a muscle cell, for a brain cell, for a nerve cell. So all of these different types of cells, all of these different types of things are found in your DNA, okay? Now, the important thing here is that your DNA is made up of only 4 molecules, okay? And we call these molecules A, T, G, and C. So just 4 molecules, they contain all of this different type of information. And this might seem kind of crazy or kind of bizarre, but the alphabet, for instance, it has 26 letters, and you can make thousands of words. And with DNA, it has 4 letters, and you can make thousands of proteins. You can make all of this different type of information with just these 4 letters, okay? So, if I went through and I took your DNA and I actually tried to read it. So your DNA comes out as all of these different letters. It's just these 4 letters, A, T, G, and C, that repeat in different ways, okay? So you can, if I took your DNA, it might look something like this. Now this might look kind of funny or bizarre, like how are you supposed to read any of this? But it's just like reading a book. So for instance, if you have a book, how do you know where to start in terms of a sentence? Usually there's a capital letter, okay? And how do you know where to end? Well, usually there's a period. So it's the same thing in your DNA. There's very specific starting and stop points. So I won't go into it, but for instance, if you see an AUG, then that's kind of like a capital letter. That's where it starts. And if you see a TAG, that's where it ends. So you can go through your entire DNA sequence. You can go through all of these thousands of letters, and you can actually read it the same way you would read a book. It's just like reading sentences in a book. Now, what happens, and I guess maybe just to recap a bit, so every single cell in your body contains 3 billion letters of DNA. So 3 billion letters of these A's, T's, G's, and C's, just as I showed you over here. And every time you have a new cell, it needs a copy of all of this DNA. It needs a copy of all these 3 billion letters. And sometimes, when you copy that DNA, there's going to be a mistake. And that kind of makes sense. If you're, just think if you were transcribing or copying 3 billion letters, there might be a mistake every once in a while, okay? And most mistakes, they make no difference, okay? You can still read the meaning, you can still understand everything. So for instance, there's some typos here, but you still can understand the meaning here, right? The mistakes don't really make that much of a difference. But sometimes just one letter, so a mistake in just one letter can make a huge difference. So for instance, illegally parked cars will be fine, right? It's missing that one letter, that one D, and that completely inverts the meaning, right? So that can completely change sort of your understanding of what that means. And again, let's eat Timmy with and without the comma completely changes the understanding of that statement. And it's the exact same thing in proteins in your DNA. If you have one letter that could be missing in a very specific spot, then that can cause to a number of different, for instance, cancers, so these rare cancers that we're talking about. So these mistakes, or these mutations as we call them, in your DNA, sometimes they tell your cells to keep growing, okay? And this can happen randomly, and this is what we call cancer, okay? So when you get a mutation, and that mutation is so basically dangerous that it causes your cells to just keep growing and growing, that's what we call cancer. Okay? So what we do is we try and target a lot of these mutations. We try to target a lot of these proteins that are involved in these cancers. And we do this in a few different steps. Okay? So what we do, the first sort of aspect of what we do is biophysics. We do computational modeling. So we have to understand where this mutation is. We have to understand if there's, for instance, that's called a pocket in your protein where we can target a drug to. Okay? So we visualize what the protein looks like. We use these very fancy techniques, some of which you'll see later in the lab today. And we try to computationally model different structures, different drugs, and how they could fit into that pocket. Okay, then the next thing we do is we have to test these out, so we synthesize all of these molecules. We make large libraries of these compounds. So we make hundreds of these molecules. Okay, so we have the organic chemists then working together and trying to make these molecules. And then you can naturally imagine that the next step is then we take these molecules and we test them out. So we put them into cancer cells. So we grow cancer cells in a petri dish. You'll be able to see some of this today in lab as well too. And then we'll test them out and we'll see which of these compounds actually work in terms of killing the cells. And this is what we call, I guess, a more simple system. But then we actually take these molecules, we test them in larger, more complex models, and we do pharmacology experiments. Okay? And then finally from there, we actually look at them in preclinical models. So we can see, for instance, mice with tumors, for instance. So you can see we've done surgery on the mice here. They have these tumors that are in the lymph nodes. And you can see, for instance, when we administer our drug or compound, it actually shrinks the tumors quite substantially. Okay, and I've presented this as a linear process, but it's what we call iterative. So it goes back and forth many times. So it's not as though on the first try we get our best molecule, but we test it out, we see this part of the molecule works, this doesn't, we go back, we make new molecules. And it's very cyclical, it goes back and forth, and then at some point we get an optimized molecule. Okay. Now, what's really important, and something that I think we've done, or we've worked on quite a bit, is that you can see that there are many different layers of expertise here. So there's biophysics, there's organic chemistry, there's cell biology, there's pharmacology, there's, of course, looking at patient data. So many, many different fields of expertise. And it is impossible to become an expert on all of these different types of fields. And what we do is we end up working. We have many different people with different expertises that we've brought together now under one roof, under one building, that can actually work together. So they work very closely together and they expedite the full process. So by working synergistically. And I think that's a very important aspect, a very important lesson, I think, that in terms of working together, in terms of actually finding people with the right skills and being able to engage with them in the appropriate way can actually make this process go much, much faster. Okay. And as I mentioned, of course, here we try and integrate all of these steps into a single facility. Okay. So this is a new building. You'll see some of this today as well too. And I think, you know, the other sort of aspect that we're also quite proud of too is that we have a number of trainees that come into our lab, that come into our group, and part of the goal is really to, I would say, try and inspire them to work on building their own sort of intellectual property portfolios, work on building their own IP, and then trying to work on commercializing this and trying to get it into the clinic. So we've had a number of trainee students who have started with us, who have ended up building their own companies during their graduate career, during their training. So the first company that was created from our group was really focused on T-cell blood cancers. This was Janpix, and they started working on advanced preclinical drugs. There's Dalriada Drug Discovery, which has grown to be one of the largest scientific research organizations in Ontario. There's DUNAD, which also recently closed a partnership with Novartis. There's HDAX, which is working on neurodegenerative diseases. And now we have a new one, which is called Gene to Lead, and they're working on an AI platform for drug discovery. But, the key thing is that, again, this is all driven by trainees. This is all driven by students who have come through the pipeline, that have worked on this for many different years, and they were motivated and inspired enough to sort of take their technology to what we call the value inflection point, where essentially now they're ready to take it into the commercial space and try to help out with the drug discovery process. And one of the goals for today is really to help give you exposure to, as I mentioned, some of the opportunities that are available to you here, but also for yourself to start thinking about what you might want to do in the future, and how some of this could potentially be of interest. Right? So with that, I guess I think that sort of concludes my talk. But if there are any questions, I can take a few questions. If not, I'll pass it off to Andre. Great. Thanks, everyone.
You can go down at the level of the pipettes and see how much of you pulled up. So you got to stay far away just in case something comes out. Yep. That's good. Very good. Do you want to open up the falcon tube and bring it over here, and you'll pour it in? Now the second one. Exactly. Perfect. You guys are naturals. Great job. Awesome. So you still have that? Okay, so you can insert it back into there. Now pull out the pipettes.
I'm going into grade 11, and I'm not really sure on a career path, but I'm really interested in sciences, like mainly chemistry. So I'll just see where that takes me.
I'm going into grade 9, but I'm not really sure what I want to do.
My name is Carson. I'm going into grade 12, and I'm not too sure what I want to do because I'm mainly focusing on my athletics right now. So that's about it.
እንግዲህ ተመልካቾቻችን እንደምትመለከቱት የብርሃን ቴሌቪዥን ዛሬ በዩኒቨርሲቲ ኦፍ ቶሮንቶ ነው የምንገኘው። በአመት 2 ጊዜ የሚደረገውን በዶክተር ሙሉ የሚመራው የህፃናቶችን ታዳጊዎችን ወደ ቁም ነገር ለማድረስ የሚደረገውን ነው። የልጆች ፊውቸር ለወላጆች በጣም ወሳኝ ነው። ብዙ ኢትዮጵያውያኖች ዝም እንላለን በዚህ ጉዳይ ላይ። ይሄ ትንሽ ሲሪየስ ሆናችሁ ልጆቻችሁን ወደ ዩኒቨርሲቲ አምጥታችሁ እንዲህ አይነት ደስ የሚል ነገር አይተው ፊውቸራቸውን ህይወታቸውን እንዲያስተካክሉ የማድረግ ነው። እድሉ በዶክተር ሙሉ የተከፈተ ቢሆንም ዩኒቨርሲቲ ኦፍ ቶሮንቶ ሚሲሳጋ ብራንች ይሄንን እድል አብሮ በመስራት ላይ ይገኛል። ግን ዛሬ እንደተመለከትኩት መጣለው ያላችሁ ኢትዮጵያኖች ወላጆች የኢትዮጵያ ወላጆች አልመጡ፣ ሌሎች ግን ብዙዎች መጥተዋል እና ይሄን አስመልክቶ ለማሳሰብ ጭምር ነው። አንዳንድ ጊዜ ኦፖርቹኒቲ እድሉ ሲፈቀድልን እድሉን መጠቀም የኛ ፋንታ ነው። እንግዲህ ከአገር ተሰደን በሰው አገር ልጆች ወልደን በመኖር ላይ ነው ያለነው። እንዲህ አይነት እድል ደግሞ በጣም ትንሽ ነው። ሌሎች ብዙ ነገር አፍሪካንስ፣ ላቲና፣ ፖርቹጋል፣ ኢታሊ እንዲህ አይነት የኮሚኒቲ ስራ በጣም ነው የሚሰራው። ለልጆቻቸው ፊውቸር ይሯሯጣሉ። ለምንድን ነው እኛ እንደዚህ ማን ነው? ግን ተመልካቾቻችን ይሄንን እድል ወደፊት በአድቨርታይዝመንት በብርሃን ቴሌቪዥንም ተላልፏል። መታችሁ ልጆቻችሁን አሳትፉ፣ አታምጧቸው፣ ይመልከቱ። እጅግ በጣም ደስ የሚል ነው። እጅግ በጣም የልጆቹ ህይወትን ማስተካከል ምን ይችላል? እኛ መንገድ ካልከፈትንላቸው ማን ሊከፍትላቸው ነው? ስለዚህ ይሄ እድል አለ። ዶክተር ሙሉንና በአጠቃላይ የዚህን ግሩፕ ብርሃን ቴሌቪዥን አመሰግናለሁ። ፕሮግራሙ ሰፋ ያለ ስለሆነ በክፍል 1 እና ክፍል 2 አድርጌ አቀርብላችኋለሁ። አሁንም ከዩኒቨርሲቲ ኦፍ ቶሮንቶ ሚሲሳጋ ብርሃኑ ነኝ ከብርሃን ቴሌቪዥን። ጤና ይስጥልኝ።
ሰላም እንደምን ዋላችሁ። ዛሬ በድጋሚ ተገናኝተናል። እንደምታውቁት በአመት 2 ጊዜ የሚካሄደው የወጣቶች ሜንቶርሺፕ ፕሮግራም ነው። ዛሬ የማርችና ሰመር ዛሬ የሰመር ብሬኩን እያካሄድን ነው። ዩኒቨርሲቲ ኦፍ ቶሮንቶ ሚሲሳጋ ከ9 እስከ 12ኛ ክፍል ያሉ ሃይ ስኩል ልጆችን የኮሚኒቲያችንን በዚህ ዩኒቨርሲቲ በማምጣት የተለያዩ ሪሰርች ላቦራቶሪዎችን በማሳየት የተለያዩ ሰዎችን በማገናኘት ልጆቹ ኤክስፖዝድ እንዲሆኑ ከልጅነታቸው እያደረግን ነው። የዛሬው የጠዋቱ ፕሮግራም በጣም በቆንጆ ሁኔታ ተጠናቋል። በጣም ተደስቷል ልጆቹ። የተለያዩ ሰዎች እገዛ አድርገዋል ይሄን ነገር እንዲሳካ። ብዙ ታይም ወስዷል ኦርጋናይዝ ለማድረግ ልጆቹን ለመመዝገብ ለማምጣት እና ቆንጆ ተካሂዷል። የዛሬው በጣም ደስ ብሎኛል ለማለት ፈልጋለሁ። በጣም ብርሃን አንተንም በጣም አመሰግናለሁ። ይሄ ፕሮግራም ሁሉ ጊዜ ያው አድቨርታይዝ ይደረጋል በብርሃን ቲቪም በተለያዩ ሶሻል ሚዲያዎችም አድቨርታይዝ ይደረጋል። የኛን ኮሚኒቲ ልጆችን የሚጠቅም ነው። ይሄ የማይገኝ ኦፖርቹኒቲ ነው። እድሉን ተጠቅሜ የጀመርኩት ነው። የዛሬ 8 ዓመት ነው ይሄ ፕሮግራም የተጀመረው። የተለያዩ ልጆችን የሃይ ስኩል ተማሪዎችን በማምጣት እዚህ ልጆቹ ኤክስፖዝድ እንዲሆኑ እንደሚቻል ይሄ ዩኒቨርሲቲ መግባት እንደሚችሉ መማር እንደሚችሉ በእግዚአብሔር በሰጣቸው ተሰጥኦ መሆን የሚፈልጉትን ነገር መሆን እንዲችሉ ለማሳየት ነው ይሄ ፕሮግራም የተጀመረውና ኮሚኒቲያችን ይሄንን እድል መጠቀም አለበት እና አሁን ደግሞ እየሰፋ ነው። የኛ ኮሚኒቲ ብቻ ሳይሆን ሌላም ኮሚኒቲዎች እየጠየቁኝ የገቡ ነው። ዛሬ የተለያዩ እንዳየኸው ከተለያየ ኮሚኒቲ የመጡ ሰዎች ተደባልቀውናል ጠይቀውኝ ማለት ነውና ይሄን ኦፖርቹኒቲ መጠቀም አለብን። እድሉን ማጣት የለብንም። ዩኒቨርሲቲው ደግሞ ፕሮግራሙን ወዶታል እና ፈንድ እየሰጠ ነው እንዲሰፋ ሰፋ አድርገን እንድንጀምርና እንጠቀምበት ነው የምለው። እኔ ይሄንን እድል ተጠቅመን ብዙ ነገር ልጆቻችንን ከብዙ ነገር ማምጣት እንችላለን፣ ሞቲቬት ማድረግ እንችላለን፣ ኢንስፓየር ማድረግ እንችላለን እና እንጠቀምበት እድሉን ነው የምለው። ይሄንን ነው ማለት የምችለው። ሌላው አሁን መናገር የምፈልገው ልጆቹ እዚህ መጥተው ኤክስፖዝ ሲሆኑ ከተለያየ ዲፓርትመንት ኮላቦሬት እያደረኩኝ ይሰራለሁና ከማኔጅመንቱም ጋርና የተለያየ ስኮላርሺፕ ፕሮግራም እንዳለ የተለያየ ኦፖርቹኒቲ እንዳለ መጥተው እዚህ አሁን ጠዋትን ፕሬዘንት ያደረጉ ሰዎች አሉ። ያን ነገር ልጆቹ እንዲያውቁ ኢንፎርሜሽን ነው ዋናው ነገር። ኢንፎርሜሽን ካገኙ ራሳቸው ናቪጌት አድርገው የሚፈልጉት ቦታ መሄድ ይችላሉና ይሄ አንደኛ እንደ ኢንፎርሜሽን ነው ልጆቹን ኤክስፖዝ ማድረግ ነው። ሁለተኛ ደግሞ ለኮሚኒቲያችንም ይጠቅማል። የኮሚኒቲያችን ልጆች እንዲጠቀሙ ነው ይሄን ፕሮግራም የጀመርኩት። ሌሎች መተው ቴክ ኦቨር እንዳያደርጉት ወላጆች ልጆቻችሁን በማስመዝገብ በማምጣት በማሳየት እንድትተባበሩ በአመት 2 ጊዜ ነው እና አንድ አድርሳችሁ ነው የምትሄድ። ሙሉ ቀን ይውላሉ እዚህ። ከዛ ፒክ ማድረግ ነው ልጆቹን እና ብዙ ኮሚትመንት የሚጠይቅ አይደለም። ስራው ኦርጋናይዝ ማድረጉ አሬንጅ ማድረጉ ብዙ ልፋትና ብዙ አለው። ግን ልጆች አምጥቶ ልጆቻችሁን ኤክስፖዝ ማድረጉ ይጠቅማል ለኮሚኒቲያችን ብዬ አስባለሁ። አመሰግናለሁ። ብርሃን።
ሰላም፣ አምሳለ ታደሰ እባላለሁኝ። ዛሬ እዚህ ዩኒቨርሲቲ ኦፍ ቶሮንቶ ነው የምንገኘው የሜንተርሺፕ ፕሮግራም ላይ ከዶክተር ሙሉ ጋር ኦርጋናይዝ ያደረገችውን ፕሮግራም በጣም ደስ ብሎኛል ፓርቲሲፔት በማድረጌ። እኔ ራሴ እዚህ ትምህርት ቤት ነው የተማርኩት፣ ሰው ተመልሼ መምጣቴ ደስ ብሎኛል። ግን ከዛ በላይ ደግሞ ደስ የሚለው እዚህ ያሉትን የኛን የኮሚኒቲ ልጆች ወጣቶች ማየታችን ነው። ከሃይ ስኩል ደረጃ ያሉ ተማሪዎች ናቸው እዚህ ያሉት ፓርቲሲፔት የሚያደርጉት ሜንተርሺፕ ፕሮግራሙ ላይ። በጣም ጥሩነቱ ምንድነው ከዚህ ከትንሽነታቸው ጀምሮ ካሳየናቸው መንገዱን ከከፈትንላቸው በኋላ አይከብዳቸውም። የሚያስቸግረውን ቦታ የሚቀለውን ቦታ እንዴት ነው የሚወጡት የሚገቡት የሚለውን ካሳየናቸው ኔትወርክ ከከፈትንላቸው ለወደፊት ይቀላቸዋል ማለት ነውና በጣም ደስ ብሎኛል በመምጣቴ ፓርቲሲፔት በማድረጌ። ለወደፊትም ደግሞ ፓርቲሲፔት ለማድረግ ፕሮሚስ እገባለሁ ለዶክተር ሙሉ። ቴንክ ዩ በጣም እሺ። ለወላጆች ስማ ዋናው እኔም ራሴ ወላጅ ነኝ። ለወላጆች እንግዲህ የምለው ልጆቻችሁን ላኩ፣ ፓርቲሲፔት እንዲያደርጉ ላኳቸው። በራሳችሁ ተቀምጣችሁ ሪሶርሱ ስለማይኖራችሁ ስለማታውቁ ሼር ማድረግ መቻል አለባችሁ ከሚያውቅ ከገባ ሰው ጋር እና ላኳቸው እንዲመጡ ፓርቲሲፔት እንዲያደርጉ። ምንም እንኳን ቢማሩ ከዚህ ፕሮግራም አንድ ነገር ይዘው የሚወጡት ምንድነው እነሱን የሚመስል ሰው በዚህ ፊልድ ውስጥ መኖሩን አይተው መውጣታቸው፣ በሳይንስ ውስጥ በሄልዝ ሳይንስ ውስጥ አይተው መውጣታቸው በዚህ ቀን ጠቃሚ ነውና ለቤተሰቦቻቸው እንግዲህ ምለው እኔ ወላጅ ነኝ፣ አደራችሁን ልጆቻችሁን ላኩ ነው ምለው።
ሰላም ፍስሐ እባላለሁ። ዛሬ ያለሁት ዩኒቨርሲቲ ኦፍ ቶሮንቶ ሚሲሳጋ ካምፓስ ነው። የመጣሁበት ዋና ዓላማ የሃይ ስኩል ተማሪዎችን በሪሰርች እና በሜዲሲናል ቢልዲንግ ላይ ሪሰርች እና ሜንቶር ለማድረግ ነው። ይሄ ደግሞ በየአመቱ ከዶክተር ሙሉ ገለቱ ጋር የምናደርገው ነገር ነው። ይሄ አሁን ከተቋቋመ ኦልሞስት 8 ዓመት ነው። እባካችሁ ወገኖች ይሄ በጣም ጥሩ አጋጣሚ ነው፣ ጥሩ ኦፖርቹኒቲ ነው። ልጆች ወላጆቻችሁን ልጆቻችሁን ላኩ ኢንስፓየር እንዲደረጉ። ምክንያቱም ዩኒቨርሲቲ ካሁኑ ከሃይ ስኩል ጀምሮ ከመጡና ኤክስፒሪየንስ ካደረጉት በኋላ አይቸግራቸውም። ይሄ በጣም ጥሩ አጋጣሚ ነው እና እባካችሁ ይህን አጋጣሚ ተጠቅማችሁ እህታችንንም አግዟት፣ ወገኖቻችንን ልጆቻችንን ይዛችሁ ነውና take this opportunity እና በጣም ጥሩ እድል ነው። እግዚአብሔር ይስጥልን። በጣም አመሰግናለሁ።
Okay, because lens has a certain diameter, right? At the bottom of it, it has a tiny lens and it has a certain diameter. Okay, the bigger the diameter, the more you would get the magnification in life, and the better the magnification.